15. And let's start the presentation. So today we're going to finish with the metaclasses that we were talking about last week and show a few examples of how to use them, particularly how to do type checking in Python if you want to enforce type checking, how to do C-style enumerations, and another example I don't remember, we'll see it later. Then there is a topic I want to start, which we'll take then for the next few sessions, which is multi-threading, multiprocessing. And we'll start today with coroutines. So what they are, how they're used, how to use them inside the normal Python code, and so on. And then we'll take it from there from next session with multi-threading a bit more in depth. There's a lot changing in coroutines right now. So there's new method coming up in every minor version of Python. So we will look at the old school coroutine before 3.7, but I will mention when things are changing and what it's happening. But before we go into that, a quick recall of what metaclasses are, right? So a class is an object of the type, right? A class is an object and its type is type. And a class is a subclass of object. So if you want to create a class for classes, you have to subclass type. That's basically what metaclasses are, right? And well, so a metaclass is a subclass of type, of type, and can be used to instantiate other objects overwriting the standard type behaviors. Let me reduce the faces here. So like this, and let's start here. All right. So that's basically the basics. Warning, most of what metaclasses do can actually be done in other ways. There's a few problems that are better solved with metaclasses because of the simplicity of how the code is organized and the readability, but most of it can really be done in other ways. Today, we will see exactly those specific cases which are not possible to do in any other way. And in particular, because they use this method, which is prepare. Prepare is very peculiar. It creates the dictionary that is used for the namespace. So this is done usually behind the scenes for you. When you initialize a class, the class body gets evaluated statement by statement. Everything that gets defined in the body of the class will be then saved into the namespace of the class in this dictionary, which is usually an ordered dictionary, normal order dictionary. With this prepare method, what you can do is you create another object that responds to set item and get item. And you can use this as the namespace dictionary. So by changing the behavior of this object, you change the way the class behaves, which is pretty deep, right? I mean, usually this stuff is in a compiler for other languages. So let's see a few examples before we move then to coroutines. And let's go also here full screen. And let's go to the first example. So we want to implement type safety in Python. We want to check when you press a function that the argument of the functions are actually of that particular type. And what we can do is we can do it with metaclasses. Now, in this case, we don't use yet prepare. But so what are we doing? Let's take one step by after the other. Do you remember we talked about descriptors? Descriptors are basically getter and setters for fields in Python. So instead of saving the value in the field, you save a descriptor in the field, and then you basically can use these getter and setters automatically. When you try to assign a value to an instance, it will use the set. When you try to write the value from the instance, we'll use the get, because this is how the argument lookup, the fields lookup of Python works. So by doing this, what we can do is that when we use the setter on this type property, we check if the value is of the type that we initialize this type property with, right? So we initialize this self type to be int. Then if somebody tries to put a string in value during the setter, if is not instance string, then we go and raise exception, right? This is done at runtime. It's expensive. It's not like in C where it's compiled and then everything is safe, but it's really done every time in a dynamic way. So usually it's not done in Python, but it can be useful, for example, if you want to to check dynamically all your code and then deactivate it when you go into production. Forget is pretty easy. I mean, we have a default value. We check first of all if we have an instance. The instance is the object on which this getter is called. If it is no, we just return the type property itself. But if there is an instance, then we just return whatever it's in our dict. That's basically it. So we set the default. If there is nothing in the dict, we just set the default and return. So how do we use this type property in a generic class? We want to just define a new class now that it's type safe. And I mean, for every class that we want to define this way, we want to do it in the same way. We define a meta class, which is type safe. And in the init, so when we initialize the class, not the object, when we initialize the class, we go and check every annotation in the items of the class. So the annotation contains all the fields and their types as you annotated them. Usually we do this for documentation, the column, int, column, string, but you can actually look at them at runtime. And once we do that, we go through them and we just substitute the original attribute with a type property attribute. So we just go on and change the members of the class by taking the int attribute and we put in a new type property int attribute instead, right? So when you then use it, so I create my class fo, which is a meta class type safe. I put up a member which is bar float 0.1, and then this is my default value, right? This lands right here in self default equal default. And then I do some printing just to see what it shows in dictionary, what is bar, and so on. But then I assign fo bar 0.4, and I expect it to work. But if I assign fo bar equal a, I expect to raise an exception, right? Make sense? Any question about how the code is structured or why that should it work or shouldn't work? All right, so let's play it. And that's basically where we are. So first of all, we got the exception. Bar must be float. It's pretty tiny, but I hope you can make it. And the rest is showing us what we're looking at. So let's go back here. We're printing the dictionary. We're printing what is bar. And there is another print inside here somewhere. Yes, we're printing the dictionary also when we leave the class. So we expect this to be the same as this, right? And have it 2 times. Let's run it again. So we have in the dictionary, we have a bar class float. And then we have our type property. There we go, right? So we have the type property inside the dictionary and it's printing the value. The fo bar is type property as we would expect. Seems that everything worked properly, right?
A bit about the first line in the printing. The object is address, and
the first line in the printing, you mean?
The object at a series.
This is just the memory address of the object where this is just saved. So if you have different objects of the same type, you want to differentiate them by the address. For example, we run it 2 times. One time was at this address, one time is at this address, right? But this one is the same as this because we are printing the same object. In this case, the class, which is an object of type property. Type safe. All right, so that's one way, for example, to use meta classes. Let's go for another example, which is a bit more involved. And this is the enumeration. So now we're using prepare. And in prepare, we are basically substituting the standard dictionary with our enum dictionary. The enum dictionary is Okay, let's take a step back. What happens if we evaluate without a metaclasses, if you evaluate this body, red, green, orange? Who can give me an explanation of what should happen? These things are not defined, right? Yet. Just random words. Any guess? Exception? Would it run? Would it do anything? No such name known, right? No such name exists. Right. Why? Because what happens when he tries to do this? It looks into the namespace, right? And checks, did I already define this attribute? Did I already define this name? If yes, then I'm executing this name, right? I'm evaluating it. If not, I give an exception. So what's the trick here to actually make it so that it works? We have to have a relaxed dictionary that if I ask him, do you see this guy? He says, yes, I saw it already, and just give me a value for it, right? So it basically enumerates my new values without me assigning any value to it. I mean, of course, I could just go and do red equal 1, sorry, equal, not plus, equal 1, green equal 2, orange equal 3. Of course, that works. Then I don't need the meta classes, but I'm just wanted to show you how you can do this in a rather more elegant and inventive way. So what we do is we create a new dictionary, a dictionary that's more relaxed again with get items. And so in the get item of my enum dictionary, what I do is I check, first of all, I check that my key doesn't start with underscore so that I can smuggle in some other property that is not enumerated automatically. But if it's not a private one, I just assign a new value to whatever key is, and I save it into my dictionary. I mean, this is super subclass of dictionary, so I can always say self key equal to next self counter. So this starts counting. Whenever I ask him something, it gives me a new number. And then I just return get item from super. Set items is just use super and just printing out that we're using it, but nothing else, right? So that we can track what's going on. Questions about this? So shall we see if it works? All right, so let's look at what's going on here. So I am printing every set I get that I take, that I'm calling, right? So I have, first of all, I'm getting my name and getting my module, my qualified name, and so on. These are all things that are inside the standard initialization of the class. And then I'm starting getting red. Okay, so what the body evaluation of the of Python does is sees red, goes into the namespace, gets red, no value, creates a value, and then takes this value and sets it back to 0. So setting red. I'm doing this in the getting, right? And the same goes on. Getting green, getting orange. Then I print orange, and my result is 2. It's what I would expect. So this is, again, one way to use prepare to change the behavior of your class body. Clear? Let's move on then. All right. So different case. What we want to do here is to support this kind of things. In some languages, you can write the same function and just overload it with different number of arguments, or actually different types. Now, we could actually also implement the different types. It's a bit more involved. You saw how we do type checking, or you have annotations inside Python, so you could actually do all these also for different types. This implementation is just to differentiate between different number of arguments, all right? But you can extend it. So how can we implement this in Python? You know how prepare works. So you can change the dictionary and you can implement get item and get and set item as you like. Anybody has an idea? This doesn't work in Python usually, right? You have the same name defined 2 times, you just overwrite it. So what would you do to change prepare so that it actually supports this? You can change the function name, yes, but then it's not overloading, right? I mean, then you're using standard. Oh yeah, internally. Okay, yeah, good idea. So the way this is done is by actually using the so let's take it a step by the time. So the way it is done is by supporting basically a multi-dictionary. What I do is I save instead of each value, instead of one value in the dictionary, I save a list of values. And whenever I get a new value for the dictionary, I just append it to the list. So this way I can redefine bar many times, my function, just append the implementation, which is the function itself, into the namespace. So, I mean, this is pretty easy. What it does is by get item, it just returns the last value. But by set item is going through the keys. If the keys is not there, it's just initialize an empty string and then it appends one, right? So this is my dictionary. So what I'm going to do when I use it, first of all, prepare return multi-dict, but we are not still there because we need to handle the number of arguments. We need to select the right function when I pass the right number of arguments in the namespace. And this is not yet done. I mean, the multi-dictionary just is able to save, but this is not enough. So what we do is in the new, right? We go to, right. So the new passes you the metaclasses that is our overload the metaclass, the name of the new class, the basis, and the attributes. And what we do is we go through the attributes. This is the content of the class body, right? And we see if it's callable, then we pass it to a special class, which is our overload, which you looked before, and we save it into our dictionary. These are the real attributes. And if it's not callable, we just put the values -1. Now, the values -1 is exactly this guy. And we just finish. The magic happens in overload. In overload, in call, we check what is called the arity, so the length of our arguments. If the length of my arguments is something, what I have to do is basically just look into my original list that I got from the initialization of the body through my multi-dictionary and select the right arity, right? So I use this infrastructure to save all my functions implementation. Then when I get called, I check the number of arguments. I go back to the original namespace, and then I select within that the particular one that I want, ordered by arity, right? It's a bit convoluted, but
Does it work if you change the order? So if you use bar self after bar self comma fix.
That's interesting. Yes, it works because we order it by arity, right? So it's implemented. I wouldn't lie. It should be implemented directly in the dict.
The dictionary is ordered. Oh yes.
Yeah. The dictionary is ordered, so you don't have to actually worry about it. And you basically initialize your FS here with the arity, and you just pass it the function that you have in the list.
Question.
Yeah.
So the class FOO. So the input parameter is the class because it has the same name as the previous class.
This one.
Yeah.
This is the superclass. Right, so I just defined, because I don't want the metaclasses to be visible. This is something that you will see a lot when metaclasses are used. You don't want the people to actually write metaclass equal to something. You just write a base class where the metaclass is used, and then you inherit from that. So you never see the metaclasses. I mean, metaclasses are usually used in libraries. So what you do is you create a base class, and then you subclass that base class. And the rest is basically behind the scenes.
One thing is so here I can use superclass as the input parameter of that class.
No, this is basically just the standard way for Python to define what class you are extending. So when you define a class, these are the superclasses. Okay. You can put one or more.
Okay.
They're just going. So nothing special there.
Okay, just like at the top, we define a class and then it's type image that we inheriting something from. Okay, yeah.
Right.
Yeah.
So I think somebody is chatting me up. I don't know why.
What am I doing? Oh yeah, sorry, that's just like a feedback.
Yes. All right. Let me do something so that I don't get annoyed by this. All right. All right. So let's run it. It's working. Well, it's a bit of magic. Okay, it's a bit complex and it's a bit over complex, but it's one of the few things that actually you can't do anywhere else. You really, if you want to mess at this level, like support new kind of language features, then you have to do it in Metaclasses, right? Let's go to the last example that I had, and then we can close with Metaclasses. And this was, I don't even remember what was. Oh yeah, right. One thing that you can do in Metaclasses, which is pretty cool, is you can support. We don't even have to run this. You can support the Q args. So you can define new classes by giving parametric arguments. So you can define, for example, something at the class level where you have like, I don't know, the required role for to access this this particular class functionality, or you can put like things like statically enforced times out or something like that. I mean, something that is what you need at class level. You cannot do at instance level, but you need to parameterize beforehand. You can put it in the class definition, and you can use them in new. So, I mean, we'll run it just for the sake of it. And in the new, you have the dictionary with all your parameters. The moment that you are still defining the class, right? So you can change things right there. You can pass, for example, what the superclass should be. I mean, I want to extend this or that. I don't know.
It's nice to use if you have memory allocation, right?
For example. Right, and you create the object with already all this data inside, right? So it's also a useful thing. Right, there are a few things that are new that I don't have in the slides or here. Now that you have init subclasses also, so for things like when you even to initialize subclasses, you would need metaclasses before that, but now you can just use init subclasses and you don't need to start a metaclass for it. And the get item at class level has also been implemented. So if you want to get the class name A parenthesis 1, until a few months ago, or I don't know, a year ago, you would have to implement a meta class. Now they have also actually a class get item. So you can implement this at the class level as well, right? And then it will respond as a basically a static method. So they linked that the get item at class level to something that you don't have to implement a meta class. Just a disclaimer. So for this stuff, now you can actually avoid meta classes. All right. So that was about meta classes. Anything, any question about this? Otherwise, I'll just close the topic forever.
So all of the meta classes that we're showing are already implemented in libraries, right? Like the enum library exists.
The enum, in that way, I might exist. I've never seen it. The overloading, I don't think anyone is using it. They're just basically crazy examples to show you what you can do with meta classes. Yeah.
There's a bit more like a string version of it.
Cool. Could be. So let's move to coroutines. All right, coroutines. Coroutines is basically just a piece of schedulable code, okay, nothing else. So usually when you describe a function, when you call it, it gets evaluated right away. When you call the function with parentheses, you get through the call, then every statement in the function gets evaluated. If you call a coroutine, it doesn't get evaluated. You have actually first to send it through basically a loop with some statement to run it. It can be that, or it can be called within another coroutine and then be awaited, as you say. So there's a different difference. So a coroutine is marked by the keyword async. So if you have a function and you want to mark this as a coroutine, you mark it as async def function, right? And that's basically it. And you can't mix them with normal functions. You can just call a coroutine from a normal function. It will the interpreter will tell you the coroutine was never awaited, and that's why you can't do it. A coroutine can be called within another coroutine by using await. Okay, so if you write in coroutine, you can just write a coroutine that you intend to run alone, but you can also integrate it in another coroutine and then run it as part of this coroutine. You can always use functions, normal functions within coroutine, of course. You can use print within a coroutine, that's not a problem, but you cannot use coroutine within function unless you send it to a thread pool or to a loop, the main thread loop. If you want to run a coroutine, let's say, or you want to run the top coroutine or just one coroutine, what you do is you use, you get a loop, usually by doing async.io get loop, and then you use loop run until completed. As of 3.7, you have async.io.run, which basically gets the loop for you and just runs it without you taking care of the details. If you want to run a coroutine in a different thread, what you use is actually the same loop, but run an executor. Run an executor, what it does, it initializes a thread loop, a thread pool for you, takes the thread, and then runs this particular coroutine in that thread. Yes? It's greater, strictly. It's 3.9. So as of 3.9, you have async.io to thread, which does exactly all this for you. It gets the loop, it gets the thread pool, it runs a new thread in the loop with the thread pool, and so on and so forth, and then returns you the result. And then you can just await for that, and that's it.
Wait a second question.
Yeah.
So if you have to separate a while, for example, if you want to do this async or coroutine schedule stuff, you just call this loop run in executor.
You want to run them in parallel.
Yes.
Then you use async.io getter. What's the next one? So if you want to run coroutine in parallel, there is this nice functionality, async.io.gather. You pass it a list, or actually you pass it args, one after the other of what you of coroutines, and it will run them in parallel.
But the question is, like, do you need to put like some await, like this keyword?
We'll see an example. I can't describe it to you. It's just
These are threads in Python. Right?
Depends.
Python threads.
It depends. The scheduling just schedules them. If you don't do anything, it will schedule them on the main thread. So while they are in parallel,
Yeah.
they are not. Okay.
What's the main difference between this and a thread? Like when I run in a main thread, and then I say, if I want to do something parallel, do I use a coroutine and not just open thread, do something close thread, or wait for it? So
It's the same. I mean, the point is, this is a very easy interface, async.io, for most of the things you want to do. We'll see the threading, which gives you more possibilities, but async.io, it's really, really easy to use if you want to do certain things. And then there are things that it cannot do, and we'll see exactly what those are, but this will do in examples, okay? All right, that was it. We're going now to spend the rest of the day looking at examples.
Actually, I would like to, because I'm not quite familiar with this. I just want to have some motivation, motivate example, why I need this concept. So, which.
Well, I'll show you. I'll show you. One of the typical examples to use coroutines and to use multi-threading is I/O, and that's why it's also called async I/O. The point is, if you have high latency stuff that you have to wait for example, you have to connect to the internet and download something. That takes a lot of time, but it's not a lot of computing time. It's just sending a packet, waiting for it to arrive, and in the meantime, you can do other stuff, right?
Okay, and the logic is that so when you call that function, it's waiting for something, and there must be some condition for that function to continue. And when that condition is fulfilled, then this function will be continuous, right?
Yes, for example. Okay, so let's look at one example. I have written here my func, which is a simple function, and another one which is a coroutine. Okay, and in the main, I'm going to first call my func. The main is also a coroutine because otherwise it can't call another coroutine. And if I'm calling a coroutine from another coroutine, I use always await. Okay, as easy as that. Now, in the wrapper which runs my main, as of Python 3.7, you can just do async IO run main. That's it. But until then, you have to do loop equal. Now, this is 3.6, unfortunately. Loop equal async IO get event loop and then run until complete main. I hope they can still talk. Yeah. So, okay. So well, what we're going to do is basically, we can do it both ways. I mean, we can just do it from the main or just call a wrapper. I'm just wanted to show you, there's probably a good idea to always have this in a wrapper, but there's absolutely no difference between what I'm doing here and there. So, well, it's basically printing 2 times. Nothing fancy there, it's just the basic structure of the grammar. So, I mean, if you remember that you have to always use await when you call a coroutine from another coroutine, that's basically all you have to know. And then you can use coroutines.
Which means that here, if I remove the
this
async and await, it doesn't.
In this case, it doesn't make any difference. No, because I'm just running everything on the main loop and I'm running it on the main thread and I'm running it sequentially. I'm just showing you now the syntax so far, all right? So I hope the syntax is clear so we can move a little bit more complex. So now we can use get. So in this case, I have one coroutine, right, core, which I pass an argument to, it prints that argument. And what I'm doing is I'm using gather to run both of them in parallel, right? So I've scheduled them in parallel, but then how they run depends on the thread that I'm using, depends on what the loop does with them, right? I get the event loop and I just do run until complete. In this case, it will run the gather and the gather will then schedule the other things, right? So let's clear up the output here because it's getting too crowded and start again. Printing A and B, nothing fancy. Let's look into.
Could it happen that it could be 8?
Yeah.
I'm not sure. I'm not sure because this is. I'm pretty sure that I didn't look into the implementation. I'm pretty sure the gather works and schedule them sequentially. So if you have just one thread, it's going to be executed also sequentially. So it's probably deterministic. Sorry? Good question. So this actually is a bit more involved. So what we're doing here is testing what the gather brings to our table. And what we're doing is basically connecting to Google and getting the index and then printing the first 80 characters, right? Pretty easy. So I have I have the main implementation, which is a function. Then I have 2 implementations. The first one is just the coroutines, which does just call get page. The other one is a coroutine which creates an event loop and then runs it. I mean, sorry, creates an event loop, gets the main event loop, and then runs this function in a thread, right? Running executor, it will run in the thread taken by the thread pool that is initialized by the running executor. So in this case, I am assured that there is some parallelism involved because it's running in its own thread. So what I'm doing here is now testing what does it mean. I first just run the get page async normally by itself. Then what I do is I take another timestamp, and then I gather 10 copies of my get page sync, this one, right? I'm not running it in a separate thread, I'm running it in the main thread. And then I'm doing the same again with a different timestamp, but this time I'm running the one that I run in a separate thread by itself, okay? So, and then I'm printing again the timestamp. So let's see what happens. All right, so the one copy took 11 milliseconds. No, 110 milliseconds. The 10 copies run on the main thread took a bit of time, 2.1 seconds. So it's sequential, as you saw. And then the one run on its own, complete, well, each item to its own thread, or the one that were available, it ran in a factor 2 speed respect to the one. Sorry?
The new line, at least, is not atomic. That's why it looks so weird.
Yeah, no, it's not atomic. So, but the point is, they were running in parallel, as you see, and they were actually executed a lot faster, right? And this is exactly the reason why you use this stuff. If you have to collect data from 3-4 different servers, merge it together, pass it to another server, and so on, you don't want to run this stuff sequentially. It will take forever. What you want to do is to send the request, send the request, send the request, send the request, await all of them. When they arrive, gather them together, put the data together, send another request back to another guy, and so on. I mean, this is what you want to do, and it actually brings something. Questions about this? Check again what we're doing here, right? We are defining a coroutine, important. Gather doesn't work with normal functions. You have to pass it a coroutine, right? So you have to define your loop, and you have to define a running executor within a coroutine, which means that you also have to await on it and async back. Then you can pass it to the getter. Otherwise, it doesn't work. If you try to just define this and just pass loop running executor, it wouldn't work with getter. But once you've done that, then basically you have this parallelism when it comes to waiting for resources.
Another question is that if I understand correctly, so there will be execute again, and something is fulfilled, you get something, and if they get it at the same time, then there's nothing happen at the same time, but more or less they are. The conditions are fulfilled at the same time, so they will be scheduled sequentially.
Yeah, I mean, somebody will get, we'll get to that. There is a global interpreter lock, right? So nobody can execute Python in 2 threads at the same time. Okay. Only one thread can execute Python at the same time. Yeah, so and that basically makes Python thread safe, if you want. But the point is, you usually are not executing Python when you do this kind of operations. You are just waiting for resources. Yeah. That's what you're doing. So who cares, right? Okay. Well, you will get a little delay, but not relevant.
I just want to know the mechanism. What happened behind that? It doesn't matter.
Let's do a little test. This one is gonna be a bit more involved. So now define a little computation, which is it's designed so that it doesn't cache anything because it's just counting back and forth even and odd numbers until you get a result, right? So adding all the even ones, subtracting all the odd ones, and then it gets a result. I don't care what it does. It's just making the CPU busy. What I do is now I do one coroutine, just a calls count, and another coroutine that runs it in an executor in a thread of its own. And then I'm doing the same game again. I call it now 3 copies instead of 10. One time with the sync, one time in the async. Who's gonna win? What would you say? Who's gonna be faster? The sync or the async?
Same.
The sync.
Same.
Same. Any other bet? All right. Is it clear? What we're doing is the same as before, right? Sorry?
The C, they are more or less the same.
Exactly. We're just doing exactly the same as we did before. Last time we got in 1/10 of the time everything running.
No, we get the result compared.
Oh, yeah, the comparison is going to be the same.
No waiting stuff.
So first one is going to sequential, and it basically took 3 times as much. The other one went all in parallel, but took 3 times as much as well. Right? Exactly. Right? So
now run it in processes.
so that's why we need to run it in process, but not this time. Next
So
time.
if I have a problem like this, and for example, I want to do something in TensorFlow, or run something on the GPU,
The thread
and
is
I
not
want
going to
to
help
use
you.
the time to like do something else, that wouldn't work.
All right. I mean, no, that's a different story.
Okay, it would work.
That's a different story because you're basically waiting for an external resource,
Okay.
right? If you schedule something to run on the GPU, that's not the global interpreter lock.
Okay.
I don't care.
So the problem here is everything is internal and therefore it's pseudo linear as well. Like what is exactly or is the reason that it takes roughly the same time because we're not waiting for external resources which would have time difference, but the computation like the
Global interpreter lock. So what it means is that whenever you run, you interpret, you evaluate a line of not Python, but bytecode, right? So something that computes on the interpreter locks everything else.
Okay.
The interpreter can be used only by one thread at a time, and that's it. So when you're evaluating, for example, an HTTP request, you are evaluating only when you're preparing the packet, opening the socket, and sending the packet. Then it's done. You're not interpreting anything anymore. You're just waiting for a packet to come. That's it. When a packet arrives, you're going to lock again and then parse the packet and do whatever you need to do with it. But in between, it's free. Here, you actually creating a function that always blocks the CPU at every time. You're interpreting everything. Every line is going to be interpreted until it's finished. There is no gap. There is no sleep. There is nothing. I mean, I could do the same if I do time sleep. It's exactly the same thing. If I use async IO sleep, it's a different story. If I use async IO sleep, I actually signal the thread that it can give the resources free and basically let somebody else run, right? But if I use time sleep inside a coroutine, I am blocking the thread. All right? Make sense? Right, it's a bit early. Thought it would take more time.
Does the same thing count for threads? Like if I do time sleep in threads?
Threads, these are threads. This is just a simplified interface so that you can run everything you want in threads and forget about there is a threading interface.
Okay. So then probably what was the library you have to use if you want?
Async IO.
Async IO.sleep. Okay.
So let's try this.
Because then I have
So j equals 0, then let's boot async IO sleep 10, no, 10 is too much, 2. How about that?
It's in seconds.
It's 2 seconds, I think, yeah. Right? That should be fine. Shall we try this?
Yeah.
Yeah. Yeah, it was 2 milliseconds. Now let's make it a bit more. It's 2000. Well, I mean, the point is, it doesn't care because the async IO sleep, it just gives the resources free. So whether I put it in a thread or I put it in the main thread is the same. It just interrupts the thing. Is that, okay, tell me again when you're done, and that's it. Shall we try with time sleep? Mm-mm.
Yes.
That I know, yeah. All right, let's see.
What are the other measures?
Oh wait, these are the first, this is the second, and this is the third. So now you see the difference. Again, as for the computation, if I use async IO sleep, no difference because they just give the resources free and forget they're ever there. But if I use time sleep, I'm blocking the thread. So if I'm doing it in the main thread, I just gave it one print after the other with a distance of 2 seconds. If I do it in different threads, they wait all 2 seconds and then they just print 0 at the same time. Yes.
Can you go back to the code and make it async sleep again? It's still difficult because what you would want it to do is at least sleep 2000 until the end when you have all of your await done because it's awaiting effect. So you would want the last of the node at least to be make it 2000.
Valid syntax. Okay, no, this is
Count is not an async function.
it's not an async, it's not a coroutine. No, I wasn't sure. Right. Let's try this out.
You would, I think you would expect that at least until the end, to the very last point in time where you awaited everything, it should have taken 2000.
We should look at the documentation. Probably.
Maybe it's another measure of time.
Yeah. No, I don't.
Seconds and quarter seconds.
I never used it. Basically, I mean, you use it just to in long functions to say you can do something. Yeah, now if you want to interject, but I never use async IO really program it, so I don't know why it's not waiting in that
Maybe
case.
it's actually in microseconds or nanoseconds.
No, I just put 9 millions inside. It didn't make any difference. Still got the same runtime.
Is there an async IO yield?
Yield. Is there a CPU yield?
Interesting question. I don't know.
Instead of sleeping, you can if it's basically affecting the way the
That's basically sleep 0. That's sleep 0.
okay.
Yeah, but there isn't. So what you're mentioning is this. I think IO sleep 0 basically release the lock on the thread and makes other use the thread. That's what it does.
Yeah. Because we are doing time of sleep and you need to do 0.001. Then it will yield, otherwise it just yield.
Yeah, no, you can use for that. You can use async IO sleep and just pass it 0, and then it will just tell to yield the lock on the thread.
We only need to replace with like this time dot sleep. Replace time dot sleep.
And it will automatically like jump back to the thread once that's 1 point something seconds.
When it's its turn, there's a scheduler which will tell it. That's your turn.
It just says here anybody else.
Yeah, exactly. It's basic. That's basically what it does. Yes.
Otherwise, I'll come back.
Yeah. Any other question? Any other?
Yes,
Yes.
I have a question. And if I write a server, for example, then a server application, then I typically use multiple sockets. For example, I use a big select loop in my main thread, but this looks similar and also handles this kind of parallelism in a nicer way. How do I integrate something like select into this await stuff? So as far as I can see, I can only await a single thread, but can I do something like await multiplexing? Await, give me the first thing that finishes?
Yeah, I mean, that's okay. Well, how about we discuss this in detail next time? I mean,
Okay.
you can wait on several things by using gather and scheduling to their own thread, and they do all the same. But then you're waiting on the last. You're not waiting on the first.
Okay.
Okay. So if you want to actually get the first one out and process that output before you and so on, it's a bit different. You cannot do it gather. That's what I'm saying.
Okay.
Okay, you can create a closure, but it takes more time, and I don't have the examples out. So we should do it like next time, okay?
Okay. Thank you.
Then
in the context of servers as well, if I don't wait, like tentatively wait for a receiving, but like this async IO sleep, and I make it a non-blocking receiving, would that mean that's because it's triggered by an external event? Would that mean that the thread or routine still comes back, or is then there a possibility that the packet is just matched?
I don't understand the question, sorry.
So when you have a socket,
Yes.
the socket is set to be non-blocking.
All right.
Meaning it doesn't wait forever.
Right.
And when it's not blocking anything, and then you don't make a time don't sleep or a time constraint on how long to wait, but you make an asynchronous sleep.
Right.
And then it would be triggered by an external event, like I received something, blah, 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 blah. Is that still like taken care of in the async IO if an external event, so to say, triggers something?
So the point is, you have an external interrupt, an external network, for example, event, and you want to react to that socket. It depends on how it's implemented. I mean, you should be careful. Usually when you have a socket, you should actually spawn a process dedicated to that one. Not use something that like this with a global interpreter lock. I'm not sure if that is a good idea. If you have a very saltuary interaction on that socket, that maybe makes sense, but let's get to that when we get to sockets and do it in detail. It doesn't make sense to make general statements.
Okay.
Yes.
So if you want to use this async function, you need to first wrap this main function as some async adapt something, right?
If you want to use a coroutine.
Yeah, I mean, so if we want to, in our like multi-threading stuff, we have multi-threads, right?
Or if you want to use async.sleep, you cannot use it in a normal function. No, you have to use it in a coroutine.
Yeah, so we need to implement, if we want to replace with our like a time.sleep thingy to jump from this.
But it should be already a coroutine, because otherwise you couldn't. Oh, okay, you're using threads.
No, but async IO.sleep is apparently, since we got a wait on it, it's not a coroutine, so it's fine.
Yeah, but I mean, if you're using threads, it's fine anyway. So.
But we just wanted to force
Yeah.
the yield. This doesn't need to be run in async.
No, that's right. Since we don't have to wait for it, it's fine. Yeah, we can use it anyway.
So the point of using this async.sleep function is just to make it beautiful. Like before we are using the sleep 0.001 to make it sure it can jump from this current thread to another one. If we use this function, we can just like
Force the QPO.
okay, makes sense.
If it does that.
Yeah.
If it should.
Actually, so if it doesn't work, the expected result with the sleep one second, because that count is not a coroutine. So if you put the
You're absolutely right. I just saw that. Okay.
and you have to put that one to the count sync.
Yeah, so we can't use that
But
one.
Count sync, put in there before returning count, and you do a wait sync, and then print date into the count.
Yeah, we need to do it in both.
Just make count.
And you do a wait there.
And we would do the same.
You have to wait.
No.
Why not?
Because it's not
You cannot do that. So it wouldn't.
not a Mason function apparently. Sleep.
Yes,
So-
yes, it is.
Oh wait, yeah, that's what I remember. The only thing I didn't. The reason I wasn't insecure is it's because I didn't have the coroutine there. Yeah, makes sense. So, and it is in second, right? Yeah. So, and you can do it also here, but then it's not inside the executor. It doesn't make any difference. Yeah, that's the only way you can do it actually. If you want to, oops, if you want to, no, now it's gone. Yeah, I just close it. So that's nice. So the only way we can actually do this test between main thread and not main thread is by putting it here, defining this as a coroutine. No, then I cannot run it in the executor. Need to define two of them. All right, let's do this. We define this like this. And then we define the same here. And maybe let's wait for 1 second instead of 0. So in this case, I would have this. It doesn't work. I don't think it works. Anyway, let's try. Yeah. So you have to await in here. But I have a partial. Sorry? Let me remove this guy. Works. So no, it doesn't work. The 0 is not printed, you see. So because if I want to run the coroutine in the executor, count must be a coroutine. Why is it not executing? I don't know. You see it? It's doing this, but it's not doing this.
Yeah, interestingly, the other one.
No. Yeah, they all release, wait 1 second, and then they retake the control. So you can run it on the main thread as well in this case.
So,
yeah.
So then there's no difference between the gather.
Except if it would work, there would be no difference. I don't know if why it doesn't work right now. If anybody can see it, fine. Otherwise, we'll do it next time. It's a sync. I'm awaiting. Running executor. I don't see it. All right, I'll fix it for next time and then we can show again. All right.
Thank you.
Bye.
Bye.
Thanks.